Right.
Okay, I think we're live now. The group quiz isn't timed, right? So I can open that up right now.
I think you have 2 hours to do it.
I think that's sufficient.
I would hope it won't take us 2 hours to do it.
So we're opening the quiz right now?
I was just getting my stuff situated.
Oh.
The individual prep to work on.
So part 2, we were supposed to, it was really short homework, or the preparation thing is really short.
Right.
Right. I found the actual lesson quite a bit more involved than the homework.
Yeah. I read the lesson and I thought, I've got to echo, I can't handle it. I'm not talking.
If we all mute ourselves when we're not talking, the feedback should put down.
Okay.
Okay.
Okay, I'm going to try again. Okay, yay, I don't hear myself like over and over again. I felt like when I started reading the lesson, I almost thought that there was like something missing. Like they jumped immediately into, okay, now let's solve this problem. But there was nothing explaining how to solve the problem. I mean, I was able to figure it out, but I just felt like there was a lot of content missing from that. Did anybody else feel like that? I mean, I even went scrolling back up, like, did I click on the right link? Did I miss something?
I know when I got especially to the PowerPoint, I was going, wow, this is getting really involved.
So are we going to do the second one? The second part? Are we going to do questions about the first part, or what do we want to do?
So I had a couple.
Does anyone have any questions about the homework?
Yeah.
Let's start with that.
So I was just wondering if anyone could explain the 3 rules of probability. Like if you guys had different explanations that were different from the reading this week. I just felt like they're very technical terms, and if anybody had more of a kind of normal 5-year-old explanation.
0 to 1, 1, and -1 from them. That's about as simple as
pretty much what I wrote down. I think we're on the right track.
Can you hear me?
Yeah.
Okay. I had myself muted and I was talking and I was like, I can't hear me. I still had it muted. Now I've unmuted it. Okay. I was just thinking like I had to break it down into sort of like 5-year-old or layman's terms for myself. And so what I came up with was the first rule, the greater than 0 or less than 1. If you think of something having a probability of 0, it's like that means it never could happen. So it wouldn't show up in your list. And if it's, greater than 1, you can't have a probability of something greater than 1. It can't happen more than 100% of the time. So that's why it can't be more than 1. So it's, if you think of it that way, like, what are the chances of this happening? Well, it can't be more than 100% of the time, and it can't be less than 0% of the time. So that doesn't make any sense. So that's how I think of the first rule. And then the second rule, if you have a group of things, that you're trying to decide what is the probability of this and this and this and this happening, then all of those things have to end up, because 100% of the time has to be accounted for. So they all have to add up to 1. So that's how I think of that. Like, okay, if we are going to find the probability of the dice roll thing, then we know that there's 6 different numbers. We know that the probability of those all have to add up to 1, because you can't have more than 100% or less than 0%. I don't know if that's making it worse or better. The last rule was a little bit more tricky. The last rule was like, okay, if you think of how, you know, if something has to happen, or if something has a probability of happening 30% of the time, then you know the converse, that it's not going to happen 70% of the time, is true. So if you think about it, if you do 1 minus that 30% of the time that it will happen, you'll get the 70% of the time that it doesn't happen. I don't know if that helped any or not.
I like the idea of 1 being 100%.
Right.
With me.
Yeah, that thinking of it in terms of this is parts of a whole, so that if you have the whole thing, you have 100%.
How about number 4? I mean, there's the textbook, you know, just, you know, definition, but, and it kind of caught me when they say, and we really don't want to talk about discrete. And I thought, this is a bad thing, or
You were trying to say that the term discrete is, it's really technical, and it goes like to the nth degree with details, and that we don't really need to know all that we just need to understand that. I think when I think of this, that we need to understand that random things aren't really all that random, because if you plot out the probabilities of these random things happening, they will all, over time, they will form a pattern. And you can plot out that pattern. And let me look at it again just to make sure I'm not saying the wrong thing here. Yeah, so that's what they're saying, that the random variables become discrete if given enough time, you can plot out their pattern. So that's the way I think of it. So like, if you think of the dice roll thing again, we think of, oh, we have random chance, you know, when we roll the dice. But really, we don't have random chance if we roll the dice. Really, we have what is it, 0.16 any time, like 1/6 of the time, we are going to actually roll that, you know, a 4. So because we think it's a random roll, but when you plot out those random rolls over time, that variable is actually not so random. There's a pattern. So that's what I think of a discrete random variable versus like completely random. I don't know if that helped you.
Sounds good.
Okay.
That was great. You're awesome.
I mean, I might be lying, but that's how I understood it.
If you were, I wouldn't even know the difference.
Okay, are we going to do part 2 together, or did you guys already do part 2?
I didn't. I read "Do This With Your Group" and I was like, sweet, I'm done.
Okay.
So if we could do this together.
That sounds good. So an 8-sided die has 8 possible outcomes for each roll: 1, 2, 3, 4, 5, 6, 7, or 8. Count the probability of rolling a number greater than 5. So step 1, I found out what the probability of rolling like any number was. And so of course it's going to be 1 divided by 8. Yeah. And then if you and I didn't write down what that was, I guess, 0.125. It's going to come out to 0.125 is the probability of rolling any one of those numbers at any given time. And then it says greater than 5. So 6, 7, and 8 are greater than 5. So you would just add up the 0.125s for each one of those. And that comes out to 0.375.
Times 3. Yeah, there you go.
Did everybody follow? Okay.
Yes.
So on the next one, it asks what the chances, okay, last page, there it is. It asks what the chances is not getting a number greater than 5. So 1, 2, 3, 4, and 5 are all not greater than 5. So you can either just add those all up, like the 0.125s, you can add all those up. I didn't do it that way. I used the complement rule and just did 1 minus the 3.75 from the previous problem. But either way, you'll get 0.625. Everybody good? Are we ready to do the quiz? I'm not ready. I feel not prepared for this quiz. I feel like the homework was way too short, so the quiz is going to be scary. There wasn't enough practice.
There you go. But we're
Did you guys watch the tutorials for this week?
Yeah, I didn't get that far.
I didn't either, but I have a friend who's taking the same class. She's just not in our class. And she said the tutorials were really helpful. So I guess we could always pull that out if we need it during the quiz.
Okay.
Yeah.
Good
I
point.
found it really helpful. He makes it a little bit more practical. And there's something about a teacher explaining something besides reading words on pages.
Yeah, I agree.
I watched the video, the complement video, but I didn't watch the tutorial video. He did explain stuff in the complement video too. That was helpful because at first I was just reading the book and I felt like, okay, where's the beginning of the chapter? I'm missing it.
Right.
So I went to watch the video first, and that was quite a bit more helpful.
I kind of feel like the book focuses too much on the backstory. Like, I learned more about Columbus than I really needed to when trying to figure out probability.
Right, exactly. I was like, where is this going? Maybe they do that because they're trying to be interesting, because some people just can't read like a math textbook. That's just too
Right.
much.
I mean, I guess, but
That would actually be me. I'm all for the story.
Yeah.
Although I don't like story problems, but that's okay. Yeah.
all right, you guys got your quizzes open?
I've got mine going.
Almost there. Almost
Pulling up
there.
now.
Almost there. Slowly but surely.
The slowest computer.
Okay. Okay.
Come on.
Okay, starting quiz.
There we go.
I think 3 is true.
Define a probability.
Do you do something to figure those out?
On number 3,
Yeah.
no. I think it's just asking is this divine?
Like an accurate.
Yeah, is this a probability distribution? Well, they all total up to 1, and it's showing what the probability of each blood type is within the population. So I would say, yes, it's true.
Okay.
I mean, that's my guess.
So the logic sounds very good. I like it.
What is the probability that a randomly selected person in the United States has type O? Why are we rounding on that one? It just says what it is.
Well, that's 4,500s or
Let me send this invite to her again. Hang on.
Okay.
Hi. Welcome aboard.
Hello.
No, I'm done. Okay.
Well, you're in like we pretty much just started the quiz, and we just well, I think we answered question 3, but now I'm not so sure.
Okay. I'm sorry I was late. Did Donna tell you what happened? I
Yeah.
told her.
Yeah.
I think that is like the most helpful part of my car insurance policy is to have lockout service. I use that probably once a month.
Really?
I'm the worst at losing my keys or locking my car.
we finally got a police officer to help us out, like, because we didn't really want to spend, $50 to have our car come be unlocked. So we were trying for a long time.
Your connection is really bad.
Helped us out, which was really nice. Okay. Get into my contact.
Can you guys hear her? So, Lindsay, why do you think that number 3 is wrong now?
Because it says that it's really 4 is messing me up because it says round to 2 decimal places, but I wouldn't think that there's anything to calculate. You just look up there and see, okay, we'll type O is 45% of the population. But then I noticed that proportion like that. So I'm thinking, okay, what's the difference between a proportion and a probability? Maybe maybe I missed something somewhere. Or am I just reading too much into the request around?
Did you say that it was true?
Yes, at first we did. We're wondering if that's
Not correct now.
Right.
These blood types is summarized. 45, 0.40, 0.11, 0.04.
the only thing is question 4 and question 5 remind me of the, take away from 100%. Question 5 would be so that's one of the rules for the probability. But it
I would say
sounds
that
really easy.
It's true.
It's true.
Because we have the proportion of the United States with each of the blood types, and the probability of it being dispensed should go in line with the proportion because we have the numbers of how many people have each blood type.
Right. So that's why I'm wondering, why are they asking us to round?
Oh, good point. I don't know.
Because there's not really anything to solve. You just look on the thing and see, okay, well, typo has this.
It's
Yeah.
2 decimals, so it's 0.45 or 0.40. It's not 4 if it's 40, it's 0.40. If it's 25, it's 0.25. It's 2 decimals.
No, come back. Don't leave. Okay. Say it again louder.
The way I see the answer is, the reason why they say 2 decimals is because it's 0.45.
So then
Right.
we just make it 0.5?
So no, because they want 2 decimals. So they're just letting you know. So if you think it was 40%, it'd be 0.40 and not 0.4.
Oh, I see.
So if
Yes.
you think about it as a percentage based, it's going to be, instead of being 25%, it's 0.25 or
Okay.
0.50.
Which
Point-
makes sense because like 45 or 50% of the population of America has type O blood. That makes sense.
They're just saying to write it in the decimal form instead of in the actual percentage form, right?
So we're gonna rate 0.45. That's the answer.
Okay.
But it's 2 decimal places, isn't it?
That is 2 decimal places. 0.45.
Yes, but we're rounding over 2 decimal places.
We can't hear you guys.
I'm getting really bad feedback.
Yeah, I am occasionally as well.
And when you're talking,
I do?
maybe I'm frozen.
Who's
So
frozen?
whenever Kara talks, it kind of breaks in and out, and she freezes on the screen a lot.
Ah.
Okay, so I just want to.
It was just you because you were talking just now, but I don't know whose connection it is.
Okay, well, did we decide that 4 was 0.45?
0.45.
I'm good.
Okay.
Yeah. So 5 would be 0.55.
Correct.
Five is what?
0.55.
Do we need the 0 in front or no? We don't know.
No clue.
No, it shouldn't because it's already assumed that it's there.
Okay.
This is a very strange story.
Awesome.
Yeah, a dog sniffing urine. That's
Dogs guess at random. What is the probability that they will correctly identify the dish containing the specimen from the bladder cancer patient? Round the answer to 3 decimal places. So is it the same as the dice rolling thing? It would be
yeah. There's 7 bowls, so it's a
So
1.
0.07.
1 divided by 7. I got 0.142. Blah 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 blah.
Whole lot of numbers. So I think it would be 0.14 if we're rounding up to the 2.
Oh, this one says 3, so it would be 0.143. I think.
Yeah, that's what I got.
413.
Yeah, because it's 142857. So if it says to 3 decimal places, so it'd be 143.
Okay.
Recommended total of 54 trials. The dogs correctly identified.
I go with little evidence because this whole study sounds kind of shaky to me.
well, and it's less than half.
Yeah, it's not even half.
Yeah.
But then it says it is very unlikely that the dog would do this well by random chance alone. So so it says, well, he can if there's little chance that he would do that well by random chance, then evidently he can detect bladder cancer, just not 100% of the time.
Which is hard to do 100% of the time anyway.
Right.
Even with tests that we do.
All right. I'll buy that.
So
I
go
always-
with strong evidence.
Yeah, I don't like that word strong though.
Right.
It's like
Are we allowed
that's
to take this more than once?
I think you can take it twice.
That's good to know.
okay. Question 8. M&Ms are small chocolate candies. I like how they have to tell us what M&Ms are.
You know, it's
Maybe in like other countries, they don't know what those are.
Oh, you're so right. That's true. That's true. Good point. Yeah, I forget that this
Why
is
is
a
green
global
blocked
thing.
out? Are we supposed to
Okay.
figure that out ourselves?
If you're eating a bag of M&Ms, what is the probability of drawing a red colored candy?
Is it?
Oh yeah, for the ones that we have to do, candy is green.
Okay, so
Number
it would
9.
be 0.13.
Right.
question 8.
How can this be this easy?
I know, that's what I'm thinking. I feel like I'm just overthinking every question because I'm expecting it to be harder. I'm like reading so much into stuff that's not even there because I just want this to be more difficult.
Here's one question though, is I've got under green, I've got a little blue blob. Like, so there's
Right.
numbers.
Yeah.
They want us to calculate it because we know that the probability of all of them together have to add up to 1. So they want us to figure out what the missing number is.
Which is 0.18.
Oh, thank you for whoever did that math.
I haven't gotten to that point yet.
Yep,
Thanks.
either.
So just to clarify, so you basically added up the other colors all together.
Uh-huh.
And then, so the remaining would be whatever subtracted from 100.
One.
One.
That's
Yeah.
correct.
Okay. And
You
so
said you got 0.18. I got 0.16. What did maybe I did it wrong.
No, I might have done it wrong. Hold on, I'm checking.
Eight four is 0.16.
Yeah, I got 0.16 also.
Okay.
Yeah. My bad. That is
So-
my bad.
So the answer for number 8 is 0.13, right?
Yes.
Yes.
Okay. Hopefully. Yes, we'll be taking this twice. And then the probability for number 9 is 0.16.
Correct.
Okay.
Which then we will then use for number 10, and we will take 1 minus that 0.16 to find out what the other color is. Right.
It's all of the other colors added together, right?
Correct.
Okay. So it's 0.84.
Yes.
I'm never right in math, so I'm really not confident about this at all. This is review. Great.
Oh, this is like from last week.
It is. Yeah.
or less than or equal. Let's see.
That's going to be the median. So 24. Right?
How did you figure that out?
Yeah.
Because you take the minimum and the maximum and then half of the observations, which is the median.
Okay.
That's 24.
Quart above what?
So the third quartile is the top.
Oh, I thought that was 75.
Right. So wouldn't the top 25% be more than the third quartile? Because the bottom 25% is going to be
The first quartile.
yeah.
The first quartile.
The middle 25% is going to be the, from 25% to 50% is going to be the second quartile. The third quartile is going to be the ones that were 50% to 75%. So it would be anything above the third quartile is going to be in the top 25%.
Which is the maximum.
And the maximum just represents the maximum that was scored by any person.
Oh. So the third quartile?
That's what I'm saying. It would be a third.
It's so they're wanting a number, so it would be above what number? So if the top 75% stops at 27, so it would be above 27.
Yeah,
I think.
I think so too.
Above 27. That's what I got. So
Following statements is not one of the 3 rules of probability.
The second one is
Yeah, the fourth one is.
so,
It's C. I think.
well, probability is not negative.
It's C. I'm going with C is the wrong answer. Or the C, or the one that's not one of the 3 rules is C.
yeah, it's a C.
Right. Hey,
I called her, then she answered, and that's all that she needs to do.
okay, sorry. What is 12, 27?
That's what.
I think
Yes.
yes.
Yeah.
Okay. All right, are we submitting?
Here's the moment.
Go first.
I'm scared.
I'll go first.
Guys, we got 100%.
Yes, we did.
I love it.
So maybe it is easy.
Yeah, I just really wanted to make that so much harder.
You got to the point it was
Awesome.
almost too easy. You start
Yeah.
overthinking it.
Yes.
It's like it can't be this easy.
Right. I was like, no, man, I was really struggling with understanding today, and there wasn't enough practice. This has to be much harder than this. Okay.
Was it one of you guys who were asking about slope, finding the slope? Was that who I was texting today?
No, but that's so weird that you're talking about that because I was helping
No.
my daughter with her homework today on that.
Oh, okay. Because like one of my other groups, I guess, was like, how do you find the slope? And I was like, guys, it's m equals y2 minus y1 over x2 minus x1. And they're like, no, slope intercept. I'm like, that's m, or that's y equals mx plus b. And they're like, I don't understand. And I was like, I don't know who's even texting me. I'm just telling you what I know.
That's
funny.
funny.
Oh, that's funny. That explains why I was
Okay.
helping your daughter with it.
Are we done with our broadcast? Should I stop it real quick?
We're done.
Okay, so stay here for a second because I have a question.